Don't write comments. Should you write comments in your code? Comments are often seen as a necessary evil in programming. They can help to explain what the code is doing, but they can also be messy and outdated. In this article, I argue that you should only use comments when absolutely necessary. In most cases, you can improve your code by making it more readable and self-documenting. Avoiding excessive comments in code is a practice that promotes clarity and enhances the overall quality of programming. While comments can provide valuable explanations for complex sections of code, it's essential to strike a balance between commenting and writing self-explanatory code. Unnecessary comments can clutter the code base, making it harder to maintain and understand in the long run. One effective approach to minimize the need for excessive comments is to utilize meaningful variable names and constants. By choosing names that reflect the purpose and functionality of the variables, developers can create code that is more self-documenting. When a reader can understand the purpose of a variable without the need for comments, the code becomes easier to follow and maintain. If a section of code is complex enough to require a comment, it's worth considering whether simplification or refactoring is a better solution. Complex code can often be broken down into smaller, more manageable pieces, each with a clear and concise purpose. This not only reduces the need for comments, but also improves the overall maintainability of the code base. Ultimately, the goal is to create code that is not only functional, but also easily comprehensible by other developers. Striking a balance between comments and self-explanatory code ensures that the code base remains clean, efficient, and more resistant to bugs. By focusing on code clarity and readability, developers contribute to a more collaborative and efficient programming environment, making it easier for teams to collaborate, troubleshoot, and build upon existing code bases. Simplifying conditions and expressions in code is a strategy that promotes both readability and maintainability. When faced with intricate conditions, one effective approach is to employ variables to represent the different components of the condition. By assigning meaningful names to these variables, the code becomes more self-explanatory, reducing the necessity for excessive comments. Breaking down complex conditions into smaller named variables not only makes the code easier to follow, but also highlights the intention behind each part of the condition. This practice aids in understanding the logic and purpose of the code, making it more accessible to other developers who might work on it in the future. For conditions that remain complex even after variable assignment, considering the creation of separate functions is a wise choice. Extracting intricate conditions into their own dedicated functions enhances code clarity and reusability. These functions can be given descriptive names, effectively acting as comments in the form of code. The main advantage of this approach is that the core logic of the condition is encapsulated with a function, allowing the rest of the code to be more concise and focused. Simplifying conditions and expressions not only results in more comprehensible code, but also contributes to a more efficient development process. By utilizing variables and possibly creating dedicated functions, developers can navigate complex logic with ease and minimize the need for extraneous comments. This practice leads to a code base that is both cleaner and more approachable, enabling better collaboration among developers and smoother maintenance over time. Leveraging types and data structures to replace comments is a powerful technique that enhances code clarity and reduces ambiguity. By utilizing appropriate types, developers can convey the intended purpose and behavior of variables and objects directly within the code, eliminating the need for explanatory comments. A prime example of this approach is seen in C++, where the introduction of unique pointers has revolutionized object ownership and memory management. Instead of relying on comments to document who is responsible for freeing memory, unique pointers explicitly indicate ownership. This mechanism not only serves as a clear indicator of memory ownership, but also offers a layer of safety by preventing memory leaks and ensuring proper resource management. The use of types extends beyond memory management. In many programming languages, utilizing types can replace comments that explain the role and significance of variables. By choosing well-named types and data structures, developers provide a natural form of documentation that communicates the purpose and constraints of the code elements. Ultimately, the benefit of replacing comments with types lies in the enhancement of code reliability and maintainability. Types offer tangible guarantees about behavior and usage that comments cannot provide. The code base becomes more self-documenting and less prone to errors that arise from outdated or inaccurate comments. Replacing comments with comprehensive documentation is a practice that elevates code understanding and fosters effective collaboration among developers. Documentation, as opposed to comments, provides a systematic and structured approach to describing code behavior and usage. At its core, documentation serves as a beacon for high-level architecture and API explanation. It outlines the purpose and functionality of classes, functions, and methods, giving developers a bird's-eye view of the code's organization and capabilities. This broader perspective is particularly valuable for those new to the code base or those looking for quick references. Documentation also excels at detailing the expectations associated with interfaces, thread safety, and possible states. By explicitly defining these aspects, documentation empowers developers to interact with the code base safely and confidently. Understanding how to use the code correctly while avoiding pitfalls and edge cases contributes to smoother development and maintenance workflows. The emergence of tools like Doxygen, PyDoc, and JavaDoc has made generating documentation directly from code files a seamless process. These tools extract well-structured comments and annotations to create documents that remains in sync with the code base. This automation streamlines the documentation process and ensures that code changes are accurately reflected in the documentation. Documentation emerges as a superior alternative to comments due to its comprehensive and organized nature. It encapsulates high-level insights, API explanations, and usage expectations, enhancing code clarity and facilitating team collaboration. As development practices evolve, leveraging tools to automate documentation generation further enhances the efficiency of this practice, leading to well-documented code that is accessible and adaptable to all developers. Comments serve a crucial role in conveying specific information that might not be readily apparent from the code itself. There are distinct scenarios where comments become invaluable assets, contributing to understanding and maintaining the code base. One such instance is when non-obvious code optimizations are implemented for performance reasons. In situations where code appears counterintuitive or deviates from conventional practices, a comment can shed light on the underlying rationale. By explaining the performance gains achieved through the chosen approach, developers can comprehend the trade-offs made and avoid unnecessary modifications that might inadvertently degrade performance. Another vital application of comments arises when a specific mathematical principle or algorithm is employed within the code. While the code may execute complex calculations or implement intricate algorithms, the context and origin of these methods might not be immediately clear. Comments that reference external sources or scholarly works provide valuable context and demonstrate the foundation upon which the code is built. This not only aids in understanding the code's functionality, but also encourages developers to explore underlying concepts further. When linking to external sources, comments should be accompanied by concise explanations that summarize the relevance of the source material to the code's execution. This way, developers can quickly grasp the essence of the reference material without having to delve deep into external references. Code supremacy in expressing intent is further highlighted by its inherent precision. Unlike comments that can inadvertently diverge from the actual code base, code is executed verbatim. This accuracy ensures that the intent of the developer is effectively translated into action, mitigating the risk of misunderstanding or misinterpretation. While comments about code can provide context, they often introduce a layer of separation that can lead to discrepancies between what is said and what is executed. By focusing on writing code that is as self-explanatory as possible, developers can foster a culture of reliance on the code itself to convey meaning. So what do you think? Let me know in the comments below, and don't forget to like, share, and subscribe to the channel. Meanwhile, thanks for watching.